Hey everybody, this is Larry. This is day 23 of April, or 22, it's April 22nd. I don't know, I've been saying it weird lately. But April 22nd, I'm trying to do an extra bonus algo problem that I haven't done yet. So let's get to it. Let's do an RNG problem. And today we have a medium problem, 2898, maximum linear stock score. I'm like half sneezing again still. Just like in the other video, allergies is kicking my butt still. Yeah, let's take a look. Given a one indexed integer array prices, where prices of I is the price of a particular stock on ith day, your task is to select some of the elements of prices such that your selection is linear. What does that mean? A selection indexes where indexes is one index integer array of length k, which is a subsequence of 1, 2, n is linear if for 1 less than j less than equal to k. Man, I have no idea. Okay. I mean, it's linear as in it's a linear graph, but that is still a really weird way of saying it. What is the constraints? 10 to the 5th, 10 to the 9. Okay. And what are we trying to do? The score is equal to the sum of the array, which is the linear array indexes, or the price of them. So 245, why is 245 linear? Oh, the indexes for 245 is linear. So it's one index, so it's 2, 4, and 5. That's linear. That makes sense. Okay. Yeah. Okay. So the thing with linear, right, is that basically now you have this idea. So this is something that comes up randomly here and here. So it's a little bit. I don't know. Like I think the first time I've seen this principle used, I didn't know how to do it. To be honest, or like I think I did it some like crazy complicated way. But knowing this does save you, right? Which is that okay? First of all, let's say you have this array, right? Then now we can map them to just something what you expect them to be, right? I mean, you can say 1, 1, but it doesn't really matter, right? Because their indexes don't really like whether it's 0 index or 1 index doesn't matter. I don't know why they put on 1 index, but because it's still the same, right? It's linear. And then you have 2, 5, 3, I suppose, 4, 7, and then 5, 8, right? And the idea here is that it's linear if so basically the way that I would think about it. So I'm just trying to think about how to explain it, right? Which is actually pretty. It's not that difficult, to be honest, but it is something that if you haven't thought about it, maybe it's a little bit trickier. I'm just trying to set it up so that I could put it on the screen. So hang on a second. Where's my pen? Okay. So basically the idea is that, okay, now that you kind of, win these maps, so then now you have these points that are just like in random places, right? And of course each I index can only have one thing, so it is what it is. But and then the idea of this linear is that you have this thing, and then you go right 1, up 1, right 1, up 1, and then you have this linear thing, right? Pretty straightforward. Not drawn to scale as you can see, but you get the idea. But then what does that mean, right? That means that if you kind of how do I say this? Actually, I don't know the mathematical thing for it, huh? Or like the visual representation of the mathematical thing, right? But the idea here is that okay, what if we made this line a straight line from left to right? I mean, it's always a straight line, and the idea here is just that okay, well, if we want to make it a straight line with respect to the first point, then it will look like this, and of course, that means that here, if it's 2 to the right, it will intersect at the 2 point, and that means that you want this to in essence y minus x for all the inputs. And with that in mind, then now it becomes a lot easier. Possible. Well, I mean, it is one of the big components. I haven't really thought through the rest of the problems yet, right? So then now we can do something like for I in range of n, right? Prices of I minus I, right? And then now what? Yeah, and then now it just becomes now that you have this thing of how far up or below the line. Okay, let me go back to the drawing a second, right? So then what does this mean, right? Essentially now, sorry, let me pull it up real quick. Essentially now you have these lines, right? So, okay, yeah. Okay, let me just erase it then. Yeah, hang on. It's not an easy visualization to make if you haven't seen it before. That's why I'm trying to be like very careful, right? So then now you have this line, right? So let's say you have these points, and then now you have this line, you have this line that goes, you know, this way, and then this line and so forth, right? And now you can think about them as just rotated, now shifted downwards on this line, right? And by 45 degrees really exactly, because that's how this works. So then now, if you think about it that way, now you have basically, why is my computer not, oh, my paint thing is not working. Why is it not deleting? Maybe my keyboard's not, oh, my keyboard's not working. Why is my keyboard not working? All right. Did I unplug my keyboard or something? Huh. That's very weird. Okay. Sorry, friends. Technology issues. Okay, so then now that means that you just have all these lines, and then you just have to count out the most of these, right? So that's basically the idea, and that's all we need to do. Because then now, let's say you have f is equal to collection.counter, and I don't know why I use f. It's not really a frequency thing, but now for the collinear lines, in the way that this is formulated, now we have for I in range of n, right? So prices sub I, and you could really put in the same loop, but I just want to illustrate this. So then now prices sub I will have that flat line, you know, on how high it is. So then now we want to add it to the thing, and that's pretty much it. Oh, I guess in this case we need to add the original price. So maybe I did mess up here, right? In that the original price is this plus I, because I don't know. Now this looks a little bit awkward the way we did it, but all right, let me rewrite this, right? So then now new index, or yeah, new index is equal to prices sub I minus I, and then now you have this thing, right? F of new index, we add it to the prices sub I, because that's how much we make from this. And then now f dot values, right? Because all the max, my USB thing is like just being weird right now. And that's pretty much it. Unless I'm wrong, then I have to keep going. But yeah, way not easy if you haven't seen this idea of like mapping that before. I think another way to think about it though is that if you kind of think about it as a grid, actually this is maybe a little bit better, which was, oh snap, sorry, I still had the screen on, huh? Okay, so this is my code. Sorry friends, made a mistake, but the code is so short you didn't really miss much. I just kind of mixed it up. But the new index is this thing, and then you add it by looking up what has the same index and then price of I, right? So I think another way to visualize this though is not the way that I kind of drew this. This is a little bit awkward, right? Is that, okay, let's, instead of points, let's think about this as a grid, right? Sorry, hang on, technology. I mean, the code is pretty straightforward. I'll show you again in a second, hang on. Right, so now you have a grid. This is, you know, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, right? And this is just a normal grid. Technically, I wrote this a little bit weird. I should have flipped it the other way, because it's not quite the same grid as the thing, but the idea still kind of comes through. Whoops. Right, and then here, of course, the idea here is that, and the diagram is a little bit wrong, is that because of the indexing, we just want to get the diagonals, right? And of course, this is a trick in these grids as well, if you don't know it, which is that in this grid, all the diagonals are mapped, well, the two diagonals, right? One of them is this way, which you map it, but you count it if you want by y minus x, right? And then the other way is if you do the other grid, it's going to be, the invariant is that is x plus y is the same. And then the invariant of the one that we're using, the y minus x is the same. Or you can say x minus y because it's just a negative, right? So it's by symmetry, it's, you know, you get the same diagonals. So that's basically the idea. And once you have that idea down, this uses that same idea to convert it and then have a lookup for that diagonal, right? Because then now that you have these grid and the diagonal indexes, and then now you can look it up by diagonal. And the reason why we add it is that because we can use greedy. Everything that's in the same diagonal, we want to take anyway. You wouldn't like skip one. So as a result, we just said, okay, we're going to take this if we could find it, and we do. And then at the end, we just take the max of everything that matches. And that's pretty much it. This, pretty interesting poem, pretty okay poem, pretty fun poem. Don't know why it wasn't a contest. I think a lot of people would get it pretty quickly, but definitely not so much if you might struggle a little bit. But yeah, as you can see, this is linear time, linear space. Of course, this may be linear space, and of course, linear time just one pass through the loop, but or two if you count the values. So that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.